So number 20 on the review. Which of the following is false? Reference angles. So I'm drawing lots of pictures here. 213.
Because it's 2 pi r. So r times 2 equals 41. You divide 41 by 2.
So 213 is 33 past 180. So yes, that A is true. The reference angle of 97 is 83. Let's see, 97 would be just a little bit past 90. The reference angle, gentlemen, please stop. The reference angle would be that. So how much more to get to 180 does it take? 83. So C is right.
Would the reference angle also be 7, or is that?
No, it's always to the x-axis. The reference angle is always, always, always to the x-axis. In fact, looking at answer choice B, because the angle to the x-axis is always less than 90, so there's no way that's right. Reference angle is always going to be less than 90. But 417, I wouldn't want to mess with that anyway. I would do coterminal and get 57. And so the coterminal angle of 57, the reference angle for 57 would be 57. For part D, we already figured out the answer is B, but let's look at D anyway. Add 360 to get a coterminal angle. 120 would be a little bit past 90. That's 120, and we need to go 60 more to get to the x-axis. So yeah, D is right. B is the wrong one. If I'd have really been paying attention, I could have known that right away, because reference angles are always less than 90. Or 90 or less. I guess it could be 90. Do we need to do 21? Kind of the same question in radians? Okay. Reference angle of 7 pi over 9 is pi over 9. Let's see. Halfway around is pi. So 7/9 is most of the way around. How much more would I need to go to get to pi? 2 pi over 9. So that's not true. 17 pi over 6. That's too big. I don't want to mess with that. Let's subtract pi. Let's subtract 2 pi. So my coterminal angle is 5 pi over 6. Wait a minute. I don't know if that's the reference angle. 5 pi over 6 is almost pi again. So what's that reference angle? 1 pi over 6. We've already done 5 over 6. We need to go 1 pi over 6 more. So C's not right. 13 pi over 8. 13 over 8. It's definitely more than 1. Is it more than 3 pi over 2? Oh, fraction experts needed here. 13 over 8.
It's like slightly less. It's 1/8 less.
You sure?
Yeah.
It'd be 13/8 would be 1/8 more.
Yeah, 12/8 is 1/8.
So it's into the fourth quadrant. So 13 over 8 puts me right there. How many more over 8 do I need to go to get to the... If I'm at 13 over 8, how many more to get to 2 pi? Would be 3. Would be 16 over 8. So 3 pi over 8. So yeah, that works. Let's see. 13. Do we want to you want to work on D? I mean, we know the answer, but do we need to get more practice with D, or are we good?
You just need 2.
I think that one would be. No?
Could you do?
Let's see.
Could you do
That's too big. I'm going to subtract 2 pi. So I get 3 pi over 5. Uh-oh, what quadrant is 3 pi over 5 in?
I mean second, yeah.
Yeah, not the second, it's not as big as pi, so it's into the second. So how many more pi over 5s do I need to get to pi? 2 pi over 5.
This type of question, you even need to look at you just
Just have to see
subtract
which
it out.
fraction
What
is
is it?
the
Just
worst.
So the question is, do I need to look at the graph?
like is it-
I would say, well, I guess technically no, you don't need to. Most of us need to, though, because I think it's a lot easier if you're looking at the picture to figure out.
you just multiply the bottom until it's closest to the top.
Now,
and it's not-
Yeah, if you could say, well, I just need to get to 0 or pi or 2 pi, what's the closest one? I guess you could do that. We're 2 pi away, or 2/9 away from pi, so 2 pi over 9. This one we're only 1/6 away from pi. That one we're 3 away from 2 pi. Yeah, you could do it without the picture. Not recommended, but could be done. What other questions? A couple of puzzle problems. We haven't done arc length and sector area in a while. Do we need to do one of those?
Could you use sector formula?
How about number 18 or 14, excuse me. Also 15 and 16 somehow aren't even on there, but let's do 14. Find the radius. Oh, this is going to be a backwards type problem of a sector with area 18 pi, central angle 7 pi over 9. Okay, well, let's just back up and do the area formula. So pi r squared is the full area times angle over 2 pi would get us the sector area. So let's start filling things in. Area is 18 pi. The pi's could cancel on this side. So r squared over 2, and theta is 7 pi over 9. Oh, we got fraction issues. Although we have a calculator, so it should be okay. Hopefully we know how to use a calculator. So that looks weird with fractions and fractions and fractions. What would you do first to start to get r squared by itself?
Oh.
I'd multiply by 2. In fact, I might not even use the calculator yet. 36 pi equals r squared times 7 pi over 9. Multiply by 9. 324 equals r squared. Oops, 324 pi equals, wait a minute, equals r squared times 7 pi. Let's divide by, you know what, let's switch to decimals here. 324 pi divided by, oh, I'm glad we picked this question. Because if I divide by 7 pi like this, that's going to give me the wrong answer. Because that divides by 7 and then multiplies by pi. Your calculator knows order of operations and follows order of operations. 324. You could X out the pi and do this on your own. That would probably be the wisest way to go. Because that answer is not right. Because I want to divide by 7 pi like that. That's the answer. And those are different. Now you're right. If you were smart, you'd get rid of the pi's on your own and just do 324 divided by 7 and be fine. R squared equals 46.285. I bet that's an answer choice. Oh, it's not. But it's not the answer because I need to square root that. 6.8. So there it is. That's probably the hardest algebra one there is. But you have a calculator, so be careful with fractions. Ty? Because my formula is pi r squared, that's the regular area of a circle, times the angle over 2 pi, and it told me that the angle was 7 pi over 9. So that's where the 7 pi over 9 came from. And then there's 14 different ways to go from there. Coterminal, SOHCAHTOA, ladder problem. Okay. 2 ways to go. So again, I would start with 0 and 2 pi, and then kind of work backwards from there. Whoops, that one's in degrees. Let's do the one in radians. 0 and 2 pi. Halfway around is pi. Half of that's pi over 2. What's halfway between 0 and pi over 2? Half of a half is a fourth. So pi over 4. Then I would go count by pi over 4. 1 pi over 4, 2 pi over 4, 3 pi over 4, 4 over 4, 5 over 4, 6 over 4, which is 3 pi over 2, 7 over 4, 8 over 4. So there's only a few that you need to memorize. The rest you can figure out. What's this? What's that angle? This angle. Pi over 6. I contend if you know those 3, you can figure out the rest, because you can count your way around. You can do the halves. You can count. So this is 1 over 6. That one's 2 over 6. 3 over 6. 4 over 6. 5 over 6. 6 over 6. 7 over 6. Yeah, it's hard to say one thing and write something else. 8 over 6. 9 over 6. 10 over 6. 11 over 6. And did we do the highlighter thing in here? Like all the shallow angles are over 6. You don't have to know that, but it may help you. All the shallow angles are over 6. All the steep angles are over 3. And all the middle angles are over 4. Again, don't have to memorize that, but maybe it helps you as you're labeling things. There's tons more symmetry in there, but we'll stop there for now. Most of you are probably going to do the degree one first, because you're more comfortable with that, and that's okay. 30, 60, 90, 120, 150, and so on. And if you get stuck, you can just convert. Like if you're not sure of a particular angle, so take 30, do times pi over 180, and you end up with pi over 6. So, I mean, I wouldn't do that for every single angle around the circle, but if you got stuck on one or you wanted to check, you can do the conversion to make sure that you're on the right track. Other questions? Yes, what you got?
Can you do 10 and 11? Like,
Coterminal?
Yeah, and then
Sure. Coterminal. So coterminal means add or subtract 360 if we're in degrees, but 2 pi if we're in radians. Which of the following is not coterminal? So if I'm going to add 2 pi, I need to do it with the common denominator. So that'd be 10 pi over 5. Right? Hopefully you can do common denominators without having to write everything out. So 3 pi over 5 would be one coterminal angle. And I can just keep adding 2 pi.
Even if it would be 3 pi over 5, even though it's the negative 7 pi over 5.
Yeah, because those would land at the same spot. 13 pi over 5 works. I could keep adding, but I look at my answer choices and there aren't any more positives, so I'm gonna stop adding 10 pi over 5. Not because it's wrong, it's because there aren't any answer choices that look like that. Negative 7 pi over 5 minus 10 pi over 5. So that would be negative 17 pi over 5. That's an answer choice. So I'm pretty sure it's A. Maybe I subtract one more time. But that gets me to negative 27 pi over 5. So yeah, not A. So all of those angles land at the same spot. Negative 7 pi over 5, 3 pi over 5, 13 pi over 5. Like all of these are coterminal. They have the same landing spot. Different ways of getting there, but the same landing spot. Number 11, arc length equals r times theta. The radius is 5. The angle is 5 pi over 4. So that would be 25 pi over 4, although the answers don't look like that. They look like decimals, so I'll grab the calculator.
Do you have to put the 25 in?
No, because it's in the top. It's when you're dividing by, you'd have to be careful. So it wouldn't be wrong if you did. 25 pi divided by 4. 19.6. Answer choice A. Do we need to do 12? It's a bit of a backwards problem. Ty? I just put it in the calculator. So the answer is 25 pi over 4, but that's not an answer choice. So I want the decimal equivalent of 25 pi over 4. So I use my calculator to learn that 25 pi over 4 is 19.6. .5 pi over 4 is an exact answer. 19.6 is a rounded answer. It's another way to say it. Yeah. If the length of the arc, okay, so L equals R theta, but this time it's telling me the length is 14. So 14 goes in for L. The radius is 8. What is the central angle in degrees? So what do I need to do to get theta by itself? Divide by 8. So let's go to the calculator. 1.75. Boy, it's sure tempting to mark A. That's in radians. That 1.75 is in radians. Also, if you tried to draw this out, even if you just sketched it, if the radius is 8 and you want your arc length to be 14, I don't know, maybe that's 8 and then some more. I don't know, just trying to rough sketch 14. That's definitely more than 1.75 degrees. It's 1.75 radians, but we know how to convert radians to degrees. Pi radians is 180 degrees. So 1.75 times 180 divided by pi. 100.3. And that makes a lot more sense in my picture than 1.75. But that's the trick answer. I don't know where the other answers come from. Yes, Olivia?
How did you know that the 1.75 was in radians?
Good question, because for this formula, that's a really good question. Theta is always in radians. Theta has to be in radians to use that formula, which means if you're using that formula to find the angle, you're going to get an angle in radians. It sort of took care of itself on number 11 because the angle they gave us was in radians, so I didn't have to worry about it. But this one, when they said this degrees, that's what threw us off. I haven't done much SOHCAHTOA. Is that because SOHCAHTOA is easy? Goodness, this is, you know this already. This is laid out exactly like the test is laid out. You okay with 27? Just be careful about where the theta is. That means this side is opposite. This side is adjacent and this side is hypotenuse. They also kind of try to jack us up by not putting the partners together, right? Sine and cosecant go together. Cosine and secant go together. Tangent and cotangent go together. And a squared plus b squared equals c squared. And then we're ready to go. Now we got everything and everybody's labeled. So, ka, toa. Can you use what?
Put a 3. So square root of 21.
Well, it's not a 2, 3, 5 triangle. 2 squared plus b squared equals 5 squared. B squared equals 25 minus 4 square root of 21, which doesn't have a nice square root. So we just leave it as square root of 21.